Bismillahirrahmanirrahim. Assalamu alaikum. So today our video is about how to analyze data using two-way Anova in species. Before starting analysis of this given example using two-way Anova, this is important to note that how you will enter your data from your questionnaire in species where we can use the two-way Anova. So I have considered here an example which have three variables. That's drug, the three drugs A, drug B, and diet, the four diets, diet 1, diet 2, diet 3, and diet 4. And a continuous variable, that's the results of these drug and diets. So this is important that you have to know that how you enter your data from your questionnaire or from any data set, so where we can analyze this data using the two-way Anova. So I have considered here an example which we'll normally discuss in our classrooms or in our questionnaires. So here we have this example, and we have diet, drug, that's drug A, drug B, drug C, and these are diets, diet 1, diet 2, diet 3, and diet 4. And these are the results, that's a continuous variable. So we have four categories in variables, that's a very categorical variable diet and a categorical variable, that's a drug. So here the drug A and a diet 1 provide a result 6, and a drug A and diet 1 provide a second result, that's 6.8, and drug A and diet 2 provide a result 9, and a drug A and diet provide a result, second result, that is 10.1. So these are the continuous variables data set, and these are the two categorical variable, that's a drug and diet. So I have entered this in species. You can see here in variable view we have a variable drug, and that's the values 1 for drug A, 2 for drug B, and 3 for drug C. The second categorical variable is diet, that we have four diets, that's a 1 for diet 1, 2 for diet 2, 3 for diet 3, and 4 for diet 4. And a continuous variable, that's a dependent variable, is a result of these drug and diet interaction result. Okay, so now this is the three variable that's in data view. We can see here a drug A and diet 1 is provide a result 6, and drug A diet 1 provide a result 6.8. Drug B and diet 1 is provide a result 4.5, and drug B and diet 1 provide a result 5.2, and so on, which I have here discussed. These are the results has been entered in species from this example. So now we have here three hypotheses. That's diet have no significant difference among diet 1, diet 2, diet 3, and diet 4 have no differences. The drug A, drug B, and drug C have no same result. There is no significant difference, and the drugs and diet have do not interact. But that's an interaction term between these two, that's drug and diet. But in alternative or research hypothesis, the diet have significant differences. They are not providing same results. The diet is not providing the same results. The drugs is not providing the same results, and there is an interaction exists between the two variable, that's drug and diet. So now let's start how to analyze this data in a species. So these are the three variables. The first step is to analyze, and remember that in this analyze we have never there is a two-way Anova mentioned here. So this is important that because in compare means you can see here one way ANOVA, but for two way here is no two way ANOVA is visible. So what you have to do, you have to click on general linear model, that's univariate, and now from here you have to shift the dependent variable, that's our continuous variable result, and drug to the fixed factor, and diet, that's a categorical variable, to the fixed factor. Okay, so now here we have many options, but the most important we will here analyze data using the plots and the options. In plots, here this is for two-way ANOVA, that's the drug. You have to shift it to the horizontal axis and then add it. Next is diet, now in horizontal axis, and then add. So these two are added individual effect among the drug and among the diet. And now you have to shift horizontal axis to drug and diet to the separate lines. So this is the interaction term. Okay, now next continue, and now we need an option, that's we need some descriptive statistics, that's for to display the means. I shift drug here in display means, for diet display means, and drug and diet display means, and compare means effect. I need here descriptive statistic. You can use the homogeneity test, that the variances, but here is many things, but in this video will become very long, so I just use here descriptive statistics. Okay, so the level of significance is 0.05. Normally we use in our research. Okay, so continue and then okay. Now this is the output. You can see here the dependent variable. Okay, I start from first here. Okay, so now this is the drug and this is the diet. The diet have 4 categories: 1, 2, 3, diet 1, diet 2, diet 3, and diet 4. And the drug have 4 categories: A, B, C. Okay, now here in every this is the drug A. Using diet 1 provide the mean value 6.4 with standard deviation 0.56569 with 2 observation, and diet 2 is 9.55, that provides standard deviation 0.77782 with 2 observation. But now we come here, the most important that's we are going to discuss is the two-way ANOVA table. So this is the two-way ANOVA table, and you can see here the drug is providing the sum of square 12.653, as we have 3 drugs. So 3 minus 1 is provide 2 degree of freedom, and the mean square value is 6.327, where the if value is 40.276, and the significance, there's a highly significance. So this is the evidence that the drug effect are not same, and all the 3 drugs is providing different results. They have not same effect. Okay, now in diet we have 4 diets providing the sum of square, that's 81.638. We have 4 diets, so 4 minus 1, there's a 3 degree of freedom, 27.213, that's the mean square, and the F value is 173.237, where the P value is 0.0001, which is quite less than 0.05, providing the evidence, strong evidence that all diets have different effect. They are not same, so we reject our null hypothesis for drug, and we reject our null hypothesis for diet. And we conclude that drug have different result and diet have different results. Now we have here an interaction term, that is drug and diet, providing a value sum of square, that's a type 3.673 with 6 that are degree of freedom, because we have 4, and this 2 and 3 we will multiply, so they are providing 6, because the degree of freedom is the observation of one the variable -1, that's observation, and the second -1, and we multiply that, so 2 3 is 6. So providing 0.112, that a mean square error, and the if value is 0.714 and 0.645. So here this evidence about that we cannot reject our null hypothesis about the interaction of the drug and dive. So we accept our null hypothesis H0 because the evidence is not supporting our alternative hypothesis. So this is the two-way ANOVA table where we conclude different results from this our data. Okay, so now this is individually, like look at the drug, that's a dependent variable. Here is providing the evidence. Look at that the mean value is within the confidence interval. Here the B value within the confidence interval, and the third value 6.762 is also within the confidence interval. So we conclude here that the both have a different effect here. So this was the video about the two-way analysis of variance, and how to enter the data for two-way analysis of variance, and how to analyze the data two-way analysis of variance. So thank you very much. You can send me your feedback in comments. So please subscribe and like the video.